All right. So it's my pleasure to introduce to you today's speaker, Dr. Ellie Boyle. Dr. Boyle works in the field of philosophy of mind and psychology. She specializes in research on non-human minds. She obtained her master's and PhD in philosophy in Cambridge, after which she also became a research fellow at Trinity Hall, also in Cambridge. And currently she has a joint position at the Center for Science of Thought at the University of Bonn and the Leverhulme Center for the Future of Intelligence at the University of Cambridge. And today she will be telling us about the classification in comparative science. And it's very nice that she's going to talk about differences between humans and non-humans, because her cat might also make an appearance today in the screen. Yeah, please, Ellie, take it away.
Thanks. Oh, sorry. So can you all hear me okay? Awesome. Yeah, so as Nadine was saying, today I want to talk about an area of research that I'm going to call comparative cognitive science. And comparative cognitive science is a term I'm using very broadly to refer to scientific projects that compare cognition and cognitive capacities in human and non-human systems. So that most obviously includes research in comparative psychology and comparative cognition, but I also mean for it to include research in artificial intelligence insofar as that research involves making or establishing comparative claims about the cognitive capacities of artificial systems or agents. And more specifically, within comparative cognitive science, I'm interested in a particular sort of project, which I'm calling a classificatory project. And that's a project that's concerned with a question like, does this non-human system have cognitive capacities of the same kind that we do? Does it have the same kinds of cognitive capacities as us? And I call these classificatory projects or classificatory questions because they're about whether the capacities of non-human and human systems can be classified into the same kinds. So many research programs in comparative psychology are quite explicitly organized around questions of this kind. They ask questions like, do animals have such and such capacity that we take ourselves to have, like episodic memory or mind reading or causal cognition, stuff like that. I don't think that these sorts of questions structure research in artificial intelligence to quite the same degree. I think research there is often less capacity oriented and more kind of task oriented. Can artificial intelligences do things that we're interested in? But along the way, researchers at least sometimes appear to attribute human cognitive capacities to AI, and questions about whether artificial intelligences have human-like cognitive capacities, I think, structure our thinking about AI in an important way. So these kinds of questions come up in relation to AI research, even if they don't structure it as they do in comparative psychology. So these classificatory projects, I think, often generate a certain kind of debate, which quite frequently becomes unproductive in a way that I'll describe in a bit more detail. And so my interest in this talk is in why those kinds of disputes arise, what they're really about, and what we should do about them. So just to give a bit more context, here are a few examples of the sorts of projects or questions that I'm interested in, and the debates that they've given rise to. And this isn't a kind of systematic overview in any way. This is just a kind of collection of places where I've seen this kind of dispute arising. You might have your own examples. So first, let's suppose that we're interested in the question, do rats have empathy? Are they empathetic? So on the one hand, it's been observed that rats engage in certain kinds of prosocial behavior, which is sometimes taken to be evidence that they are empathetic. So for instance, they'll take action to release a trapped conspecific from a restraining cage at no obvious benefit to themselves. But they don't take similar action to open empty cages or ones containing neutral objects. So researchers have sometimes characterized this as empathetic behavior, suggesting that the rats are acting in response to the emotional state of the conspecific with a view to ameliorating it. But on the other hand, skeptics have responded that we don't know whether we should classify this behavior as empathetic because we don't know whether it's properly responsive to the other rat's distress. And to establish this, you'd need to show that the rats stop trying to release the trapped rat if the trapped rat stops acting all worked up, or that the rats would move away from the trapped rat if that alleviated the trapped rat's distress. So there are all these kinds of further things we need to know before we can classify this behavior as empathetic. But to this, optimists might reply that that sets quite a high bar, because even in humans, empathetic behavior might not display that kind of rational sensitivity to facts. And moreover, that kind of rational sensitivity might call on other kind of extra empathetic resources that rats lack, like inhibitory control if their first impulse to go to the distressed individual needs to be inhibited. But at this point, I think it's no longer clear that there's a substantive disagreement being had about what rats are like. We might be inclined to say that the parties to this debate are agreeing on the facts about rats, but they're disagreeing about terminology, they're disagreeing about how we should use the term empathy. And so it's not clear how productive this debate is going to be. So here's a second example. Does AlphaGo have creative intelligence? AlphaGo, you might be aware, is a computer program developed by DeepMind to play the game of Go, which beat the 18-time world champion Lee Sedol 4 games to 1 in a very highly publicized match that was a huge milestone for AI. And this question about whether AlphaGo is creative or has creative intelligence arises because there was a move in the second of these games, move 37, which was so unusual, it was widely characterized as an example of creative intelligence. People said this was a move that no human Go player would ever have played. But a skeptical person might reply that we don't know whether this move was really genuinely creative, because even though it was kind of novel and surprising from the point of view of observers, it might not have been novel and surprising from the point of view of AlphaGo, because AlphaGo had played many thousands of simulated games against itself, so maybe it had tried that style of moves many times before. And if we think that creativity requires producing something that's novel and surprising, which one account of creativity says, then we might have reason to doubt that this move really was novel or surprising. But of course, an optimist might reply that those criteria are inappropriate or are being wrongly applied in this case if outputs fail to be novel or surprising because their author has considered them in advance. That sets an awfully high bar for producing anything creative. And it kind of might even reduce creativity to a sort of fluke, whereas we often think of creative outputs as the products of consideration. But who's right, again, about what creativity really is a question that's difficult to answer, and one might think is just a terminological question. So again, there's room, at least for the suspicion, that there's no kind of substantive debate being had here. Just one other example that is relevant to my research. Do animals have episodic memory? Episodic memory, as you'll probably know, is memory for personally experienced past events. There are a whole bunch of behavioral experiments that use lots of different methods and apparently provide evidence that animals remember events from their past. Most famously, of course, scrub jays appear to remember what they've buried, where and how long ago, and use that information to determine which sites to return to. But there are lots of other studies using all kinds of different criteria, which are taken by at least some people to qualify as converging evidence that animals have episodic memory. But then there are skeptics who object in a number of ways. One objection is that none of these experiments show that animals are mentally reliving past events as we do. So since that kind of mentally reliving past events is an important element of episodic memory, these experiments give us very little reason to think that animals engage in episodic memory. But optimists reply that tying episodic memory to this idea of mentally reliving effectively makes the question unanswerable. And since it's not an unanswerable question, they think we should construe it differently. And again, you might think this is beginning to look like a verbal disagreement, that the parties to this debate, again, aren't obviously having a substantive disagreement about what animals' cognitive capacities are like, but about how to use the term episodic memory, which seems like not an especially easy or interesting disagreement to resolve. And I think there's a kind of similar debate to be had about whether artificial agents have episodic memory, which I won't go into. And I think we can see versions of this pattern of dispute arising all over the place in discussions of whether animals have the capacity for imitation, theory of mind, causal reasoning, and so on. So hopefully that gives a sense of the general shape of the problem that I'm interested in and the kind of prevalence that I think it has in comparative cognitive science. In more kind of general or schematic terms, these debates tend to go like this. Some optimists claim that a set of observations provide evidence for a certain cognitive capacity in a non-human system. But then some skeptics point out that there are some either actual or at least epistemically possible differences between the non-human and the human capacity, and take this to be a reason to deny that the non-humans have the capacity. Optimists respond that this putative difference doesn't have the significance that the skeptics take it to have. It doesn't mark a difference in kind. They think that we should think about this capacity in a less restrictive way than the skeptics do. And more often than not, it begins to look as though the optimists and the skeptics may just be talking past each other. Their disagreement starts to look verbal, and then often at this point, the debate sort of stagnates. So I think this is kind of problematic, given the role that these kinds of questions occupy in comparative cognitive science, and particularly in comparative psychology. A lot of research is explicitly structured around questions like this, and yet they often end up in this kind of unproductive place. So yeah, this is sub-ideal. So very briefly, where I'm heading in this talk is I want to start by offering a kind of diagnosis of why these disputes often end up in this apparently unproductive place. And what I want to suggest is that these disputes arise in the way that they do because comparative cognitive science is a context in which the boundaries of cognitive kinds is kind of systematically indeterminate. Then I'm going to think about what we should do about that. I'll start by looking at one response that's been advocated by some prominent scientists in comparative psychology, which is called a bottom-up approach, which very briefly suggests that we should stop structuring research around these kinds of classificatory questions and instead take an approach that's more focused on neurological mechanisms. And I'm going to suggest that this response to the problem is perhaps problematic in some ways. And so I'll suggest instead that we might make progress if we took a different way of thinking about cognitive kinds and the delineation of cognitive kinds, according to which the way in which we delineate a cognitive kind or a cognitive capacity is determined by the interests of a particular project. So we have, in effect, a project relative way of thinking about what cognitive capacities are. So that's where we're going. Cool. So step one, diagnosis. So as I said, what I want to suggest is that in this section is that these disputes are not primarily about whether there are differences between human and non-human cognitive capacities, but about how to draw the boundaries of cognitive capacities or cognitive kinds. They're about how to determine whether a non-human capacity and a human one are members of the same cognitive kind, given that the human and the non-human capacity are bound to differ in certain ways. So I'm saying that these differences of opinion are about whether things differ in kind, whether they're members of the same cognitive kind. I'm conscious that I'm a philosopher and a lot of you are not. So this way of talking about things in terms of kinds may not be entirely natural or familiar. So natural kinds is a philosophical term used to refer to kind of natural groupings of things in the world. So things like species or gold or brains. Like these are collections of things that share interesting properties and seem to fall into like natural categories. And in cognitive science, we're interested in cognitive kinds, things like episodic memory or mind reading. Types of cognitive phenomenon that seem to be kind of like out there in the world and distinct from one another. And a very prominent way of thinking about cognitive kinds in philosophy, and I think implicit in a lot of cognitive science, treats them as what are called homeostatic property clusters. So a group of entities forms a homeostatic property cluster kind, just in case 4 conditions are met. The first is that these entities tend to share a cluster of interesting properties. The co-occurrence of those properties is inductively significant, which is to say they feature in useful inductions or explanations or predictions. The co-occurrence of those properties is explained in terms of the action of one or more homeostatic mechanisms, which is to say just that there are some mechanisms that explain why those properties tend to occur together in those things. And the group of entities is maximal with respect to its inductive significance, which is just to say that there's no larger group of things that does exactly the same kind of job, that features in all the same explanations and predictions and so on. So this is all a bit kind of abstract. We can concretify it a bit with an example. Putting cognitive kinds to one side and just thinking about natural kinds in general, a good example is the species Homo sapiens. So the species Homo sapiens forms a kind, a homeostatic property cluster kind, because humans, let's say, tend to share a cluster of properties. They have, certain kinds of genetic and anatomical and morphological things in common. The co-occurrence of those properties is inductively significant. We can make a bunch of interesting predictions and explanations of human phenomena by appealing to those properties. The co-occurrence of those properties is explained in terms of one or more mechanisms, primarily the mechanism of descent, we might think. And the group of entities is maximal with respect to its inductive significance. So the species Homo sapiens is such that there's no larger group of things that plays just the same role. But the group of all humans except for my grandma is not maximal in that sense. So that's why that's not a natural kind. So that's a very kind of brief whistle-stop tour of this view of natural kinds. And this is a kind of really prominent way of thinking about what cognitive kinds are in philosophy. So we might think about, let's say, memory or episodic memory in this sense. Episodic memories tend to share a cluster of properties in virtue of which they feature in interesting explanations and predictions. Because of certain mechanisms, let's say in the hippocampus and related regions. And there's no other bunch of cognitive phenomena that you can add to episodic memories and get the same kind of predictive and explanatory value. Cool. So this is the basic view of cognitive kinds that I'm just going to assume in what follows. And so our question is about, in classificatory projects, questions come up about whether human and non-human cognitive phenomena fall into the same cognitive kind, where cognitive kinds are understood in this sense. Cool. So this view of cognitive kinds is often called upon by philosophers to settle questions about kinds and kind membership. It tells you what a natural kind is, or a cognitive kind is. So if some class of phenomena fails to meet the specification of what a cognitive kind is, this view can tell you that it's not a kind. So it's often appealed to in this negative capacity to deliver a verdict that a group of phenomena are not of one kind. So for instance, it might turn out that the various things we refer to as concepts are heterogeneous. They don't all figure in the same kinds of explanations and predictions, and they're underpinned by different mechanisms. So then concepts wouldn't count as a kind, excuse me, which is an argument that's been made by Edward Mashery. Similar arguments have been made about the emotions not forming a natural kind. So this kind of use of the theory might help us to resolve some of the disputes that I was talking about just now, because it might turn out that some of the capacities that we were asking about back then don't constitute a cognitive kind, even in the human case. And if the thing that we were talking about doesn't even constitute a cognitive kind in the human case, then it's a silly question whether an instance of some capacity we found in the animal case is an instance of the same kind. So I have a suspicion, for instance, that creativity is not a single cognitive kind, but refers to a bunch of diffuse phenomena. I might be wrong about that. That's a completely uninformed opinion. But if that turned out to be the case, then the question of whether AlphaGo was creatively intelligent in just the same way as a human, whether it had a capacity of the same kind that we had, wouldn't obviously be a very sensible question, and perhaps we should abandon it. So this way of thinking about cognitive kinds can help us to resolve perhaps some of those problems. But at least some of those things that we were talking about earlier probably are cognitive kinds. So I have a suspicion that episodic memory is a cognitive kind in the sense that I've outlined, which is why I used it as an example. And it's not clear that this view of cognitive kinds, whilst it is quite good at telling you when a bunch of phenomena don't count as a kind, it's not clear that it plays well in a positive role in telling you whether something does count as a kind or whether something counts as a member in a kind. And the reasons for that are several. One is that this way of thinking about cognitive kinds tolerates significant differences between members of a kind. It only requires that members of a kind tend to share a cluster of properties, but it generally doesn't treat any properties as necessary or sufficient for kind membership. The properties that are referred to in the cluster may also be dimensional. So there may be a kind of indeterminacy or vagueness about whether the properties are present to a sufficient extent in a candidate member. And this view also appeals to mechanisms and whether something is a member of a kind is going to turn on whether the right kinds of mechanisms are responsible for it having the properties that are characteristic of the kind. But since mechanisms themselves lack clear boundaries and can be individuated at a kind of fine or coarse level of grain, there's also a kind of indeterminacy or vagueness about whether the mechanisms underpinning a candidate instance of a kind will be the same as those in humans, underpinning the kind in humans. I think, so this is kind of just a general feature of this view of cognitive kinds. It's actually supposed to be an advantage of the view because it's supposed to help us make sense of how there can be natural kinds within which there is substantial variation. And so often it will turn out that there are kind of fuzzy cases around the edges of kinds on this view, where it's kind of tricky to decide whether something counts as a member of the kind. So if we were trying to understand something about the origin of dogs, and we were looking at fossils, and we were trying to classify a fossil as a wolf or a dog, this picture of kinds would predict that somewhere there will be some fuzzy cases that are very difficult to classify into the kind wolf or dog. But that's supposed to kind of be a feature of the view. More often, at least very often, when those sorts of fuzzy cases arise, you can go some way towards settling them by thinking about archetypal members and just kind of using our judgments about which things are kind of archetypal members and comparing candidate instances to the archetype to make a judgment about whether something should or shouldn't be counted as a member of the kind. But I think in comparative cognitive science, this feature of this way of thinking about cognitive kinds becomes problematic in quite a systematic and vivid way, because comparative cognitive science involves characteristically taking a cognitive kind that has kind of been delineated for the purposes of human psychology and putting it into a completely different theoretical context, where by trying to figure out whether a non-human cognitive phenomenon satisfies the description of the kind, when we can anticipate that there will be many differences between the human and the non-human phenomenon that we're looking at. And here it seems like appealing to the archetype might be problematic. So in very general terms, I think comparative cognitive science, and in particular classificatory projects, create a situation like this. So we start out with a group of human cognitive phenomena, which we take to form a cognitive kind, and we label that kind K. And then we're interested in whether any animals have a capacity of this kind, K. So we go out and do some research, and we discover some bunch of non-human cognitive phenomena, Y, and we compare X and Y, and we find that there are similarities between X and Y, both in terms of what they do and in terms of the mechanisms that underpin them. But there are also some differences, as you'd expect, because there are going to be differences between human and non-human cognitive phenomena. So we ask whether Y belongs to K, whether it's like the same kind of cognitive capacity as the one we observed in the human case. And given what we've observed, it looks as though the answer isn't obviously no, because Y is kind of interestingly similar to X in a bunch of ways that matter from the point of view of making predictions and explanations, and is underpinned by similar mechanisms. So putting X and Y together in a cognitive kind seems to be okay. But at the same time, X has some differences from Y that are also inductively significant. So the inductive significance of X is different than that of X plus Y together. And so X looks like a kind in its own right. So the human capacity looks as though it's distinctive in certain ways, but it also looks as though it's the same sort of thing in some other ways. So on one way of looking at things, what we've actually got is potentially two cognitive kinds that we're looking at, one more and one less inclusive. And the question of whether this non-human capacity belongs to the kind K that we were talking about in the beginning resolves into the question, which of these putative kinds is K? Which kind were we talking about when we asked whether the non-humans had the same kind of cognitive capacity that we had? So how should we fix the reference of this kind term K? Well, we might appeal to the archetypal instances in human psychology, which would naturally persuade us that K was just the human capacity, because what else could we have been talking about when we asked whether animals had the human capacity? But at the same time, it should have been obvious from the beginning that any non-human instances of this capacity might differ from the human instances in some pretty substantial ways. And yet we took ourselves to be asking a sensible question, which suggests that we can't possibly have been talking about the human capacity when we asked whether animals or non-humans had K. But if we treat K as this kind of more inclusive kind, that requires that we ignore some inductively significant features of the human capacity that we might have been interested in. And it also leaves it unclear kind of what the boundaries of that more inclusive kind are. If we were asking about this more inclusive thing, that more inclusive thing would have been, at least in the beginning, completely undefined. So both answers strike us as potentially correct. There's something fine about saying that K is the more inclusive kind, and there's something right about saying that it's the less inclusive kind, but neither of these things is obviously correct. And so we end up confused. And I think this kind of indeterminacy about what cognitive kinds are, how they're delineated, and what we're even asking about when we ask whether non-humans have the capacities that we do, is in the background of, if not all, at least some of these debates that I've described in comparative cognitive science. So that's diagnosis. How are we doing? Cool. So what should we do about this? So one response that I've seen recently from some prominent comparative psychologists effectively says that we should just stop doing that. And these comparative psychologists have been advocating what they call a bottom-up approach instead. So they take the view that these classificatory projects are top-down in at least two problematic senses. Firstly, they begin and end with a kind of yes or no question about often what is a very complex cognitive capacity that we're familiar with from the human case. They demand an answer like animals either have this capacity or they don't. But without a kind of clear accepted theoretical account of what it would be for animals or non-humans to have this capacity, and without a methodology for settling those kinds of questions, that leads us into the kinds of unproductive disputes that I've been talking about. And secondly, these critics think that top-down projects are top-down in a second sense, namely that they're human-centric. They structure inquiry around human cognitive capacities, as though the goal of comparative cognitive science were to see how everything in nature compares with humans who sit at the top of a kind of intellectual scala natura. So instead of doing this, it's been suggested that we should replace these classificatory projects with more of a bottom-up approach. And on my reading, there are two ways of understanding what a bottom-up approach is, corresponding to these two senses of top-down. The first is that rather than beginning with a question like, do birds have episodic memory, or does this cognitive system have capacity X? We should instead decompose the target capacity into its component mechanisms and then ask whether those mechanisms are found in other systems. And then the second thought is that rather than beginning with a question about human cognitive capacities, we should just not ask questions about human cognitive capacities at all. We should observe animals' natural behavior and attempt to determine what mechanisms underpin those behaviors without attempting to locate those answers within a kind of human-centric framework. So for reasons of time, I'm just going to focus on the first of these versions of the bottom-up approach, the decomposition approach. And just to say a bit more about it, so with respect to the questions that I was talking about at the beginning, it would make recommendations like this. Instead of asking whether rats have empathy, which is a kind of problematic top-down question, we should instead decompose empathy into its component mechanisms and then observe rats and find out which of those mechanisms are found in rats, and then kind of abandon the further question of whether rats are empathetic. Or instead of asking whether AlphaGo is creative, we should decompose creativity into its component mechanisms and work out which of those mechanisms, if any, are present in AlphaGo. And instead of asking whether animals or artificial agents have episodic memory, we should look at the mechanisms of episodic memory and work out which ones are found in animals or artificial agents. And the further question about whether the capacities that we started out being interested in are found in these non-human systems is one that we can just avoid or bypass. So the first thing to say about this approach is that I think these recommendations are not cost neutral. I say that because I think this decomposition approach is very well suited to achieving a particular kind of theoretical interest. And I think it's conceived with that kind of interest in view, namely understanding how we got here, how human cognitive capacities evolved. I think that it's well suited for that because it will tell us at what point in evolutionary time the particular mechanisms that go into making up our cognitive capacities evolved or emerged, and potentially under what circumstances. But we ask classificatory questions, I think, with a much wider range of interests in view. And I think it's less than obvious that this decomposition approach can satisfy a wide range of theoretical interests. So we might be interested in establishing claims about animals' ethical status. And a lot of those claims seem to turn on whether animals have certain ethically significant cognitive capacities. And at first glance, at least, cognitive mechanisms don't seem to have the same kind of ethical weight as cognitive capacities. So without taking a stand on classificatory questions about whether animals have capacities that we have, it's not clear how much progress we can make with respect to those kinds of ethical interests. We might also be interested in understanding the varieties of forms that cognitive capacity can take across species, given different biological constraints and different selection pressures. And it's not clear that we can establish anything about that if we aren't willing to take a stand on whether any non-human capacities fall into the same kinds as human capacities. And we might also be interested in understanding how different cognitive capacities relate to one another and interact. For instance, how episodic memory interacts with semantic memory or with decision making or things like that. And one way to explore that would be to look at, what these different capacities look like in species that have a different suite of cognitive capacities. How, let's say, decision making is different in a creature that doesn't have episodic memory. And again, it's not clear how much progress we can make with respect to that kind of theoretical interest if we're not willing to take a stand on whether non-humans have cognitive capacities that we have. So the point is not that we shouldn't engage in bottom-up research projects, which I think are probably very useful with respect to understanding the evolution of cognition. But given these kinds of limitations, I think perhaps we ought not to be too quick to completely abandon these more kind of top-down classificatory research projects. That at least seems like there's a lot to lose by doing so. So if we were going to do that, we'd have to hope that there was a powerful reason or something to be gained. And I think advocates of these bottom-up approaches think that there is a powerful reason to do so, namely that classificatory projects are beset by all of these unresolvable indeterminacies, which we can just avoid if we adopt the bottom-up approach. But I don't think that's actually true. In fact, I want to suggest that this kind of decomposition approach is a companion in guilt with classificatory projects, which is a kind of dramatic philosophical way of saying it raises many of the same issues. Because delineating cognitive phenomena is just different at every level of organization, not just at the level of cognitive capacities. And we're still going to need to know how to delineate cognitive phenomena on the bottom-up approach. So first off, if we're going to adopt this bottom-up approach, we have to start by knowing what the capacity is in the human case. But although I said that comparative cognitive science raises these like tricky questions about delineating cognitive capacities in an especially vivid way, there are still difficult questions about how to delineate cognitive capacities, even if you restrict your attention to humans. So take episodic memory, which I'm just going to keep using as an example. There are lots of tricky questions about how to delineate episodic memory, even if you just focus on humans. So on the one hand, I think episodic memory, part of the reason that episodic memory was introduced and part of the theoretical work that it was meant to do was to mark a relatively exhaustive partition within declarative memory between, if you like, memory for facts, which is decontextualized, and more contextual memory for events or experiences. And that way of thinking about episodic memory encourages us to take a very broad view of it, on which it might encompass quite diverse things like flashbulb memories, memories that we can't locate in a personal narrative, memories for routes or places that aren't associated with a single event, but have been kind of amalgamated over time. But on the other hand, episodic memory is often characterized much more richly as a capacity for forming and retrieving and reliving detailed contextual memories of specific events, which can be located in a personal narrative. And if we think about it in that way, then many of the things that I just mentioned don't count as episodic memories. And these kinds of things, which of those views of episodic memory we take is going to matter from the perspective of a bottom-up approach, because it will make a difference to our kind of functional and mechanistic decomposition of episodic memory. On the richer characterization, episodic memory might make essential use of certain kinds of cognitive mechanisms that wouldn't feature in a mechanistic description of this sparser notion of episodic memory. So we've got kind of tricky questions about how to delineate cognitive capacities, even if we just focus on humans. Next, the bottom-up approach asks us to decompose cognitive capacities into their component mechanisms. I think there's, without taking a stand on whether any non-humans have the capacity, at least one way in which one might do that is foreclosed, because one way in which one might try to decompose a cognitive capacity into its component mechanisms would be to find an animal that had that capacity and then try and understand its mechanistic underpinnings in that animal. And if we're not willing to take a stand on whether any animals have the capacity, at least that method of mechanistically decomposing it is not open to us. Of course, there are other ways of doing it, so that's just a practical problem. But then finally, supposing we've overcome that problem, we have to judge whether the mechanisms we find in humans and the mechanisms we find in non-humans are the same. But just as there are almost certainly going to be differences between the cognitive capacities of humans and non-humans, there are almost certainly going to be differences at some fine and concrete level of detail between the mechanisms we find in human brains and the mechanisms we find in non-human brains or silicon systems. And what judgment we reach on whether the mechanisms in these non-human and human systems are the same is going to be determined by how we delineate the mechanisms themselves. So we could describe them very abstractly in information processing terms, and then we would be inclined to make more inclusive judgments about whether mechanisms were the same. Or we could describe them in very concrete neurobiological terms, and then we'd be inclined to make much less inclusive judgments about sameness. So the point is that we can't avoid difficult questions about how to delineate cognitive phenomena, even if we take this bottom-up mechanistic approach, because those kinds of questions are going to arise at every level of inquiry, particularly if we're interested in making comparisons across species where the phenomena of interest are going to differ in some concrete ways. And of course, that's what comparative cognitive science is. So that is what we're interested in. And so as long as we want to do that, we need a way of settling these questions about how to decide whether things that differ in some concrete ways are instances of the same kind. So instead, what I want to suggest is that we can make progress with these sorts of disagreement by recognizing that the theoretical project in which we're engaged plays a role in fixing the delineation of the object of study, the target phenomenon. So it's characteristic of classificatory projects in comparative cognitive science that they ask questions about cognitive capacities or kinds that are originally familiar to us from human psychology, but take them out into a context where their role in human psychology can't be called upon to settle questions about their delineation or kind or membership. So instead of trying to use archetypes or the role that the kind plays in human psychology to settle these kinds of questions about membership or the delineation of capacities, we should instead settle those kinds of questions by appealing to theoretical questions that are local to the project that we're engaged in. That is, we should try and figure out what it is we're trying to achieve and use that to fix the delineation of cognitive kinds. Going back to that picture of cognitive kinds that I was talking about before, recall that a shared cluster of properties or a bunch of things that have a shared cluster of properties qualify as a kind when that cluster of properties is inductively significant. But depending on the project that we're engaged in, it might be that only certain inductive generalizations are of interest. And so it might be that certain properties that are characteristic of a human cognitive capacity might be more important than others with respect to a particular project, depending on which inductive generalizations they feature in. And so if we're trying to make judgments about whether a non-human cognitive phenomenon falls into that kind, we might disregard certain properties characteristic of the human capacity to the extent that the generalizations they feature in are less important to our project, and treat some properties as more important to the extent that the generalizations they feature in are more central to our project. And in different projects, the answers to those questions might vary. So there's a kind of pluralism or project relativity, I think, baked into this way of thinking about kinds. I think it falls out that the right way to delineate a kind for the purposes of one scientific endeavor might not be the right way from the point of view of another cognitive endeavor. And so the right way, obviously, to delineate a kind, a cognitive capacity, if we're studying it in humans, is not going to be the right way to delineate it if we're interested in making comparative judgments. But more importantly than that, I think when we are interested in making comparative judgments, there's not just one reason for doing so. Comparative cognitive science isn't a single kind of theoretical project unified around a single aim. We ask classificatory questions in comparative cognitive science with a view to settling a diverse range of questions. And so on that basis, I think it's not surprising that comparative cognitive scientists often disagree even amongst themselves about how to delineate cognitive capacities. So suppose, just to take an example, because that was quite abstract again, that we're interested in episodic memory, a capacity that we'll say, for the sake of argument, is quite well defined in the human case. And we're interested in determining whether a capacity that's been observed in rats is episodic memory. We might answer that question in different ways depending on our interest in asking the question. So we might be interested in understanding problem solving in rats and the role that memory plays in problem solving. And so if we're interested in whether their memory capacities include episodic memory, we might delineate episodic memory in a way that highlights any features of episodic memory that we believe play a role in problem solving. But we might be less interested in how episodic memory feels. So if we decide that rats have episodic memory because they have a form of memory that plays the kind of episodic memory role in problem solving, someone might object that we don't know what rat memory feels like. But unless we think that the feeling of episodic memory is part of the role that it plays in problem solving, we might take the view that that doesn't matter for the purposes of this project. We delineate episodic memory in a broader way, such that the feeling of remembering is less important. On the other hand, we might be interested in establishing claims about rats' ethical status. And that kind of project is going to encourage us to privilege features of episodic memory that are important from the point of view of making generalizations about ethical status. And from this perspective, it might be important how episodic memory feels. And it might also be important how episodic memory interacts with other cognitive phenomena beyond problem solving, like affective phenomena. And so from this point of view, our delineation of episodic memory will at least be different and perhaps less inclusive than if we were just interested in some narrower question about problem solving. Or finally, we might be asking whether rats have episodic memory because we're interested in developing pharmaceutical treatments for Alzheimer's. From this perspective, we might think we're going to be much more fussy about the fine-grained neurobiological mechanisms that underpin memory in rats, because those are going to be relevant to making generalizations about the effectiveness of pharmaceutical treatments. Whereas with respect to the previous two projects, fine-grained differences between the mechanisms of memory in rats and humans might not be particularly relevant. So what I want to suggest is that these are kind of three legitimate projects for the purposes of which we might ask whether animals have, well, rats in particular, have episodic memory. But they might demand different and equally legitimate ways of delineating the kind episodic memory. And more generally, when we ask whether animals have a cognitive capacity that we have, our reasons for asking that question are going to play a role in fixing the delineation of the capacity. So this way of thinking about these disagreements about non-human cognitive capacities, I think bottoms out in something more interesting than a terminological dispute. So what I want to suggest is that in at least some cases, people come to different ways of delineating the cognitive kinds of interest or the cognitive capacities of interest, not for kind of trivial terminological reasons, but because there's a kind of mismatch between the theoretical projects that parties to these disputes are or take themselves to be engaged in. Or alternatively, there's a kind of failure to appreciate that there are a multiplicity of different reasons for which we might ask whether animals have cognitive capacities, and that these different projects might license different ways of thinking about how to delineate the phenomenon. And if I'm right about that, then I think there are kind of systematic good faith reasons that we end up in these difficult, apparently unresolvable disputes. But also that if we take this project relative way of thinking about cognitive kinds, they're not unresolvable. So wrapping up, I've said that comparative cognitive science generates tricky and apparently often unproductive disputes about whether non-human cognitive capacities are of the same kind as human cognitive capacities. And it does that because it systematically involves taking the kinds of human psychology and putting them to work in a context where ordinary ways of determining kind membership don't work. And this kind of generates a systematic indeterminacy about the boundaries of cognitive capacities. But we can settle those questions by recognizing that the theoretical project that we're engaged in plays a role in fixing the delineation of phenomena and localizing our delineation of capacities to particular theoretical projects. And importantly, since comparative cognitive science is not a single theoretical project, the result is a kind of pluralism. There might be multiple different ways in which it's legitimate to delineate a cognitive capacity. As a result, a lot of these, or at least some of these apparently verbal disagreements, bottom out in something I think more substantive, namely a confusion about the nature of classificatory questions, that is thinking that there is kind of just one answer and just one way of understanding these questions, or a disagreement about the reasons for asking them, a mismatch about why we should care whether animals have the cognitive capacities that we do. So the upshot is that we need not abandon asking these kinds of classificatory questions, but we also can't sensibly ask them for their own sake, as though they were kind of standalone questions that we're going to admit of a single interpretation or a single answer. We have to recognize that they can be asked only with some specific project or goal in view. And having done that, we also should bear in mind that the answers to those questions are unlikely to generalize across multiple theoretical projects. So the result is a slightly more complicated way of thinking about classificatory questions, but a way that still allows us to ask them. And that's it. Thanks very much.
Okay, let's all unmute ourselves to give Ali a big applause. Cool. I